Okay, now we're going to go into inequalities. Inequalities are where we have inequality symbols instead of the equal signs. So we have inequality symbols here. These are my 4 inequality signs. We have this organizational tool to help identify how these solutions are going to look. I would like to add one more thing to each column. Now, these columns are separated like this. Everything over here is and, everything over here is or. In the and, your number line is going to look like that. Everything between 2 numbers. Or I guess it could also be written like that. Everything between 2 numbers. Our or means that it can be anything over there or anything over here. So where the and is everything greater than and less than, or it's in between, or as it can be either be left here or right that direction. And again, if it's not the not equal sign, it would look like that. So make sure you write that down, because we'll be checking back on this later. This is the graph, the lines, the dots, equal to, not equal to. The lines equal to, we use a square brace. Not equal to, we use the curly brace. And again, what this means is my and solution means it's going to be everything in between my critical numbers, and my or means it's going to be everything on either direction of my critical numbers. So our first example is going to be pretty familiar to us. The numbers and variables are identical to the first one we looked at. Our first one was 3 equals negative x squared plus 4. Now we've changed it and put an greater than or equal to sign. My greater than or equal to sign changes this up. So no longer is it just the critical numbers that are my solutions. So everything they're saying 3 and 3. Now these are still solutions because we have the equal sign. If this did not have the equal sign, if it was just greater than, these would not be part of our solutions. But we have the equal to part, these are part of our solutions. Difference here is, though, there's a lot more numbers that are in our solutions. We need to figure out if all these numbers up here are my solutions, or are all the numbers down here, and this goes on forever, my solutions, or is it going to be everything in between? There's 2 ways we look. We're going to talk about 2 ways to look, and then we're going to talk about how to check that. We're going to still put these in the calculator because we needed those critical numbers. If we look at the graph, we're going to think about this. It says 3, and this line right here is 3. 3 is greater than my function, and this is my function here. Greater than means stuff above. So right here, is my 3 above my function? Yes, my 3 is above my function. Over here, again, my 3 is above the function. But inside, in the middle, right here, here's my 3 in here, and my function is up here. My 3 is less than, it's below. So this area in here is not part of my solution. It is not part of my solution in there. So my solution is anything from here, and it's a solid dot because it's equal to the left, and anything here to the right, because all these points are good, all these points is above, but nothing in here. We'll talk about how to write this down in a second after we look at the table. In my table, I have my critical points, and I look over here. 3 is greater than my function. My function is the one that's changing over here. 3 is bigger than 0, yes. 3 is bigger than negative 5, yes. 3 is bigger than negative 12, yes. Inside here, 3 is bigger than 4, no. 3 is bigger, yes, yes, bigger, bigger, bigger. So yeah, so all these over here are good. This does not work inside. Either way works. The way we write that is, this is x, and my critical number here is -1. And we can see that here in the table. So -1. and these values are less than, these are to the left, and equal to, or we said greater than is an or, so that's why I go in both directions like this, or x, and my special number over here is 1, and these values are greater than or equal to 1. And this would be my solution there. There's one other way that I would like for you all to know to test these. To test these, you could plug them into here. So 3 negative x squared plus 4. I always like to plug in 0 and test 0 as my special number. 0 is usually the easiest number to multiply and test in. If we did this right, 0 is in the middle here, so it should not work. So I put a 0 in here. The reason I test 0 is anything times 0 or 0 squared or anything like that is 0, which means all we're left with here is 4. So 3 is greater than or equal to 4. Is that a true statement? No, that's not. No, that doesn't work. So yeah, it has to be everything on the other sides of it.